If you've ever sat in an exam looking at a hypothesis testing question and thinking you have no idea where to start or what order to write the steps in, then this is for you. And I can tell you, it's not the fact that you're bad at maths or that you don't understand this topic. It's just the fact that you don't have a clear system. I'm Amy. I'm a maths teacher and tutor specializing in A-level maths. In this video, I'm going to share with you my exact 6-step process that you can use for nearly every binomial hypothesis testing question. So you never have to wonder what you need to be doing again. Let me show you. Let's have a look at the 6 steps you need to do every time you do a binomial hypothesis testing question. The first thing you need to do, and this quite often gets left out, and this is important not just for the exam, but for your own mindset as well. You need to define your variable. What is it that we're actually measuring? With binomial, you're looking at what are successes. So you might know that with binomial, you are looking at success and you're looking at failure. So we are going to decide what does our success looks like. So that might be how many red beads there are in a bag, how many people come into your restaurant who are vegetarian, how many elephants there are in the world living to an old age. But you need to be really clear with yourself. What is it you're counting as success and what are you measuring? The next one is to write out your distribution. So this is to do with binomials. So that's when you write X with that little squiggly line, a tilde, and that's to show you're using a binomial distribution. Now this will get you marks in the exam, and sometimes they ask directly for you to just write out the distribution. So it's really important you know how to do that step. Then you need to state your hypotheses really clear. Your null hypothesis, which is always a P equals, your probability equals something, and your alternative hypothesis, your H1, which is either less than, more than, or if it's a two-tailed test, not equal to. And I'll be showing you this in context in a minute. Number 4 is to calculate the probability of the sample that you took, so the outcome of the sample that you took. I've put in blue here, find the critical region. There is a method with the critical region. I'll show you that in another video. We're going to focus on this method of just going straight to calculating the probability. That's what I recommend. You then compare it to your significance level to see if it's below or above. And then you write your conclusion in context. This is really important. You don't just say, reject the null hypothesis or do not reject the null hypothesis. They don't care about that. They want you to say, what does this mean in the context of the question? Because this is applied maths. They want to see that you know exactly how to apply this in context. Let's get into looking at a real example. A machine fills packets with sweets and 1/7 of those packets contain a prize. Now you might notice that D is here and we're missing A, B and C. That's because I've removed the redundant things here so we can just focus on hypothesis testing. Let's have a look at the hypothesis testing part. So Camille claims that the proportion of packets containing a prize is now less than 1/7. This is crucial information. He takes a random sample of 110 packets with 9 of them containing a prize. So this is our sample data. This is what he believes to be true. This is slightly confusing here because we have to ignore all this about boxes. It doesn't say anything in our hypothesis test about boxes. We only care about how many packets contain a prize. So let's follow the steps and have a look at this one. So we need to define our variable. So X, we'll use X here because T is for something else to do with the boxes. X is, we're going to say the number of packets containing a prize. That's what we're measuring for. That's what success is. The next step is to write out the distribution. So X and then the squiggly line B, that means X can be modeled by the binomial distribution. The first number here is always going to be the number of trials or the number you took for your sample. So in this case, it's 110. This probability here is what's assumed to be true. This one here is what your null hypothesis is going to be, your probability. So it's 1/7. The assumed probability here is 1/7, that 1/7 of the packets contain a prize. That's what you have to put here. And then when we go on to step 3, state your hypotheses, H0, we always state that it's the same as this, that it's 1/7. And Camille is then saying, okay, I'm going to challenge this standard understanding, and I'm going to say, I think that the probability is now less than 1/7. And we're going to use this sample of 110 to test that. 4th step is to calculate our probability. Now, this is the bit that can sometimes be a bit confusing. You either need to do less than or equal to or more than or equal to. Now, this is a one-tailed test, and we are looking at less than, so we know we're going to be looking at this side. So less than or equal to 9. So you take your calculator, and you're going to calculate this. Now, on this ClassWiz calculator, you need to go to Home, and you need to go to distribution and choose binomial CD. If you find it a little bit confusing using your calculator and remembering where all the functions are, I do have a free guide that I've collated all of the functions together in one place. So you can flick through the guide to check what functions are needed for applied, pure, and that you'll never be wondering again where it is. So the link for that is in the description. So we're going to go to binomial CD. So you click on binomial CD, we go on to variable, and we're going to put in 9. We put 110 for sample size, and you put 1/7 for the probability. You can write in 1 divided by 7, that's fine. And then you press execute and you get your probability. So in this case, it's 0.0383. I'm just doing that to 3 significant figures. And I always suggest here that you put this as a percentage, because that is what really actually makes sense to us here. So we've done our first 4 steps. Now we need to compare it to our significance level. So this is, again, another really important bit of information is 5% significance level. So what this is saying is this is the standard, this is the boundary of whether we're going to reject or not of the null hypothesis. Let's just pause for a second and explain what's going on. Here, we're assuming that it is there's a 7th chance that we could get a prize. And that's what we're using when we're doing our test here. So this is saying that if this were true, the chance of the outcome of that test being 9 packets or less is 3.8%. So there's a really small chance that if this was true, this would be the outcome of our sample here. So because that is so unlikely, it's actually less than 5%, which is the standard we set for how unlikely it has to be to make a certain conclusion. We actually reject the null. So it's when it's a really small amount that you reject the null. If it's under the significance level, we reject the null hypothesis. So this conclusion in context isn't just going to say this. We are going to say reject the null hypothesis because it's just good practice to say that. You could say H0 as well. But we're going to write this in context. So we usually just say there is sufficient evidence that the proportion of packets containing a prize is now less than 1/7. So you could say this supports Camille's claim. The examples are really keen that you do explain this in context. Just some numbers is not going to be sufficient. So here's an example for you to look at yourself. I'm going to wait now while you give this a go. So pause the video and give this a go. Seriously, pause it. Maths is all about practicing. So if you're not pausing this now and practicing it, actually putting it into practice, then you are not going to improve on this. So pause the video. I'll wait. Okay, and I'm just going to show you the answer now. So you might notice here, that's actually really low. So you might be thinking, if there's only a 2.5% chance that this is true, given the assumed probability of 45%, then surely we have to reject. This is so unlikely. But we don't in this case, because every test is going to have a different significance level. So there's going to be a different boundary for every question. Medical studies, for example, are going to have really, really low significance levels because it has a really big impact on people's health, that they would have a really strict significance level. In things that aren't as important, like if an educational policy is making a difference on grades, it's important, but it's not as important. You might have something less strict, like 5%. Okay, so common significance levels are 1%, 5%, 10%, but there can be other ones as well. Okay, so you say that actually because 2.5% is bigger than our significance level, it's not unlikely enough that we reject, so we don't reject. So we say there is insufficient evidence to reject the null and suggest that the proportion of elephants living over 40 has reduced in capacity. So there's insufficient evidence. You need to be saying that. Now, you might be thinking, yes, that's okay for a simple, straightforward question, but what about when it's more difficult, when they ask for a p-value or they mention critical region or critical value? You might be thinking, what do all these words mean? How does this fit into the 6 steps? Well, that's exactly what I'm covering in my next video. You can click here now to have a look.